A parallelogram is a quadrilateral with two pairs of parallel sides. That's the definition of a parallelogram. But parallelograms also have many interesting and useful properties, which we can prove exist. But what is a property exactly, and how is it different from the definition? We can understand definitions and properties by looking at a familiar object, like a car. A car, by definition, is a four-wheeled, motorized passenger vehicle. If you've got a four-wheeled, motorized passenger vehicle, you've got a car. But we all know cars are more than just passenger vehicles. They have all kinds of useful properties. For example, they can also protect you on a rainy day, they can provide shade for a picnic, they can express your personality, and they can play music. Those are all extra properties of a car that aren't part of the definition. The definition is the basic model, a four-wheeled passenger vehicle. The properties are useful characteristics beyond the definition. Parallelograms have many properties, and we will prove one here. We want to prove that given a parallelogram, the opposite sides are congruent. Let's begin by stating the obvious. AB is parallel to CD, and AD is parallel to CB because of the definition of a parallelogram. Can you think of a good way to start our proof? Perhaps by now you've realized that if we create triangles, we can use our triangle congruence shortcuts to make progress. So let's draw a diagonal here. What can we do next? Let's label these angles 1, 2, 3, and 4. Can you see that angle 1 and angle 2 are alternate interior angles? Those are parallel lines. So 1 is congruent to 2 by the alternate interior angle theorem. How about 3 and 4? Same thing. Those are alternate interior angles, and these lines are parallel. So 3 is congruent to 4 by the alternate interior angle theorem. Now, step back and look at the two triangles. Can you prove them congruent? BD is congruent to itself by the reflexive property. So an angle, side, and angle of one triangle are congruent to an angle, side, and angle of another. Triangle ADB is congruent to triangle CBD by angle, side, angle. Remember, we are trying to prove opposite sides are congruent. Is that true? Yes. AB is congruent to CD, and BC is congruent to DA because corresponding parts of congruent triangles are congruent. We went from parallel lines to proving angles congruent, to proving triangles congruent, to proving sides congruent. We successfully proved the property that if a quadrilateral is a parallelogram, opposite sides are congruent. Sometimes, the converse of a property is also true, but not always. A car has the property that it protects you from the rain, but not everything that protects you from the rain is a car. That converse isn't true. The converse of our property of a parallelogram would be that if opposite sides are congruent in a quadrilateral, then it's a parallelogram. Is that true? Let's try to prove it. Let's add the given congruent sides to our drawing and a diagonal as before. Can you prove the triangles are congruent? We have two pairs of sides congruent. Can you find a third? Yes. BD is in both triangles, and BD is congruent to BD by the reflexive property. Now we can say triangle ABD is congruent to triangle CBD by side, side, side. But that doesn't make the lines parallel. We'll need to label some angles again as before. And if we can prove the pairs of angles are congruent, we will be able to prove parallel lines. Let's do it. Because the triangles are congruent, 1 is congruent to 2 by CPCTC. The same is true for 3 and 4. Now, AB is parallel to CD, and BC is parallel to DA by the converse of the alternate interior angle theorem. Do we know it's a parallelogram now? Yes. We proved opposite sides are parallel, and that means ABCD is a parallelogram, by the definition of a parallelogram. Because we proved the converse of this property, we now have a tool we can use to prove something is a parallelogram. If you see a quadrilateral with opposite sides congruent, you can use the converse of this property to prove it in one step. Like many other types of geometric objects, a parallelogram has a definition and various useful properties that we can prove. In this case, we proved that if a quadrilateral is a parallelogram, opposite sides are congruent. Sometimes we can also prove the converse of a property. In this case, we proved that if opposite sides are congruent in a quadrilateral, then it's a parallelogram. A property and its converse, two useful tools for you to use in your future proofs.